Hello everyone, welcome to SKD Institute of Physics. Myself, I am Diwakar. Today, I am going to discuss one extremely important concept in the JEE Mains and Advanced. There is a NEET and Advanced. Okay, see here. That concept is here. The heading is there. That is a conversion of the galvanometer into an ammeter. First, understand what is galvanometer. Galvanometer is a sensitive instrument. It is used to measure very small amount of current, that is 10 to the power of minus 6 or 10 to the power of minus 9. That is a micro and nano amperes. Okay, that means it is a sensitive instrument used to measure very small amount of current. Clear? Okay, we are converting the small measuring instrument into an ammeter. Ammeter is device, it is used to measure large amount of current in the order of milliamperes. Milliamperes means 10 to the power of minus 3. Clear? In this video, I am going to explain this concept in a very real life example. Don't skip the video and watch the video till the end. You can understand how the galvanometer can be converted into an ammeter. You will never forget this concept. Sure, I am sure about that. Okay, see here. Now we are going to discuss first one. What is galvanometer and how can we convert the galvanometer into an ammeter? See here. With a real life example, I am giving one very important analogy. Say here, this is a galvanometer. It having the resistance Z. Okay, if we pass the large amount of current I, the galvanometer getting damage. Without getting the damage of galvanometer, okay, without getting the damaging of galvanometer, we want to protect the galvanometer. We are connecting a small resistance that is called shunt resistance. That is called shunt resistance. Remember, a small resistance is called shunt resistance. Why we are taking the shunt resistance in parallel combination? Why you are not connected in the series combination? Okay, you can understand end of the video. Okay, if you observe carefully. Okay, see here. Now the current I is coming towards here the junction is formed. According to Kirchhoff's current law, the current is divided at the junction. The current Ig is flowing through the galvanometer and current I suffix S is flowing through the small resistance, that is a shunt resistance. Okay, again Is and Iz, these two currents are combined at the junction. Okay, and the total current I will be leave. The sum of the current entering the junction, the sum of the currents leaving the junction must be same. Okay, so here now I am giving very important analogy. You will never forget this one. See here in my thumbnail you can able to understand that one. Okay, with a traffic example I am giving this concept very clear manner. Okay, see here. If you observe carefully, without shunt in my thumbnail you can observe without shunt. Here the without shunt is there. Okay, that is whole traffic will be moving in the town. Assume this is taken as the town. This galvanometer is taken as a town. Okay, and this is a shunt resistance. Okay, I am taking the traffic as the current. I am taking this analogy. Analogy means similar. Okay, now understand. Okay, if the whole current means whole traffic will be flowing through the or moving through the town, means in the town the roads are not heavy, not wide. Moreover, the traffic jam will be occur. Moreover, it will be damaged. Okay, that's why heavy vehicles are not allowed in the town. Okay, that's why for heavy vehicles we are created a bypass. Okay, that is alternate path from the town, from this town. Okay, the light vehicles, there is a 2-wheelers, 4-wheelers, 4-wheelers like that. There are light vehicles will be move in the town and the heavy vehicles will be moving in the bypass. Okay, and these two vehicles are again at the end of the town. okay, at the end of the town. Okay, these two light vehicles and the heavy vehicles are combined and moving the highway. Okay, then you can definitely understand why the galvanometer cannot measure large amount of current. Why we are connected the shunt resistance? By connecting a shunt resistance means small resistance. Resistance is small means the current flow in the shunt resistance will be more. That's why heavy vehicles will be moving to the bypass. That's why the galvanometer, that is small measuring device, can be converted into the ammeter. Okay, this is an analogy. I hope you understand. Okay, now I will explain this one in our physics concepts. Okay, see, first one, this small resistance shunt resistance connected in the parallel means the in parallel combination, the voltage across the shunt resistance and the voltage across the galvanometer is same. According to Ohm's law, the voltage V is equal to IR, that is IZ into Z, and the voltage across the shunt resistance is IS into S. We want to calculate the value of shunt resistance. IS is equal to IZ into Z divided by IS. Clear? Now, according to the KCL, Kirchhoff's current law, the sum of currents coming towards the junction is I, and the sum of the currents leaving the junction is IC and IS. Okay, from this we can write IS is equal to I minus IC. Substitute the value of IS in this equation 1. Clear? Then we can write that is S is equal to IZ into Z divided by, in the place of IS we can write I minus IC. This is a simple formula. Okay, we are calculated how the galvanometer can be converted into an ammeter. Remember, this formula is very important for NEET and the JEE Mains concepts, and moreover advanced also. Okay, in advanced the different concepts will be linked, but very important for the NEET and the JEE Mains. Okay, we can simplify this formula in by taking the IZ as the common. Say S is equal to, we can write this one as IZ into Z divided by, if we take IZ as the common, we get the I by IZ minus 1. IZ gets cancelled, means then IS is equal to capital G divided by I by IZ minus 1. Okay, then N is equal to I by IZ. IZ is equal to I by N. That is, current flowing through the galvanometer is equal to 1 by N times of total current, where N is the sensitivity of the galvanometer. Then S is equal to capital G divided by N minus 1. Okay, this is one more formula to find out the small shunt resistance connected in the series. Okay, in this analogy help you to understand why a shunt resistance is connected in parallel. Okay, like this video, share it with your friends. Okay, subscribe my SK Institute of Physics. See you in the next concept. Okay, thank you.